Our next topic is branching. Branching is when the interpreter decides to do one thing or another based on the state of its world, usually based on the value of some variable. Branching is what really allows programs to get more interesting rather than just doing the same thing with every run. We do branching in real life. If I have money, I will go to the store. Or else, I will go to the bank. So I'll do one thing if I have money, and I'll do another thing if I don't. In Python, we'll split this into statements and code blocks. In pseudocode, we might say, if I have money, go to the store. Else, go to the bank. So we have an if statement and a code block underneath, an else statement and a code block underneath. If the first condition is true, I have money, then we execute all the code inside that code block. Otherwise, we execute all the code in the else code block. We might have another statement following these two that happens no matter what. So I will either go to the store or go to the bank, but either way I'm going to sleep afterwards. Let's suppose we own a very small zoo, and we want to direct our user based on their preferences. Our program can use an input function to find out whether the user likes animals with 2 legs or 4. We take the user's response and place it in the response variable. Notice that this is a descriptive variable. It uses a word to try to describe the kind of data we intend to place in there, rather than an X or a Y. In your programs, you should always use descriptive variables. We're going to use an if statement so that we can do some branching. We're going to react differently depending on the user's response. Remember that the input function returns a string, not an integer, even if the user types the number 2 or 4 here. Later we'll learn how to convert a string to an integer, but for now we have to be careful and say if response equals, remember that's the double equal sign, quote 2. We put it in quotes because we know we're expecting a string. And then that colon that we saw in the pseudocode. So if the response is 2, we'll react this way. Please visit the kangaroo. Otherwise, we'll provide a different reaction. Please visit the elephant. Let's run our code. The interpreter presents the prompt. Let's answer 2. And we get the reaction that we expect. Please visit the kangaroo. Let's run it again. This time we'll answer 4. And we get a different response. So that's fantastic. Except that the user might enter something else. Can you predict what would happen if the user entered a 3 instead? Please visit the elephant. Well, that doesn't make much sense. So our program is doing something interesting. It's making a decision based on the input from the user, but it seems like we need to get a little more sophisticated. Going back to our shopping example, I might say, if I have money in my pocket, go to the store. Otherwise, if I have money in the bank, go to the bank. Or else, ask my sister for money. So now I have 2 different conditions and they're nested. If I have money in my pocket, I'm going to go to the store. Otherwise, if I have money in the bank, I'm going to go to the bank. Notice, if I have money in my pocket, I'm not going to go to the bank. I'm not even going to consider that. And if neither of those things are true, then I'm going to ask my sister for money. With Python, we'll use the elif statement. If pocket money, then go to the store. Elif bank money, go to bank. And then finally, else, go to sister. So we're going to choose exactly one of these 3 options. If we have pocket money, we're going to go to the store, and we're not even going to think about the other 2 possibilities. Similarly, we're only going to think about the bank if we don't have pocket money. If, else, if. And if we don't have pocket money, but we do have bank money, we're going to go to the bank. After checking both of those possibilities and finding neither one is true, then we're going to fall to the default else. If none of the previous conditions were true, we go to the else block, and I go to my sister and ask her for money. Now let's modify our Python program to take advantage of elif. Elif requires another condition. If the response was 2, we're not even going to consider anything else. If the response was 4, we'll do this other thing. And now we want another code block for else. Else captures any other input that the user might present. Let's run the program and make sure it works. First, we should make sure that we haven't broken anything that was already working, so I'll answer 2. Please visit the kangaroo. Run it again. Answer 4. Please visit the elephant. And now last time when I answered 3, my program also said please visit the elephant, but now it says, sorry, can't help you. Now we can also create something called a nested if statement. Suppose we had more than an elephant with 4 legs. Suppose we had an elephant and a cheetah. So maybe we ask the user another question. We're placing the user's response into a new variable, response2. And if the user responds yes, we'll send them to the cheetah. Otherwise, we'll send them to the elephant. But I'm going to again use the elif statement because I got burned in the past. So now we have a whole set of if, elif, and else statements inside this condition. So if the user answers 4, we're going to get some more information from the user, and then again react differently depending on their response. We won't try all the possibilities, but let's just make sure this works. So if we say no, we get the elephant, and if we say yes, we get the cheetah. And remember, we can continue with more code after our else block. And this code, that is at the same indentation level as the if, elif, and else blocks, will be executed regardless of the response that the user gave. So just a couple more points to wrap this up. Notice that we're using the equality comparison operator that we learned about. This whole expression, response equals equals 2, is converted into either true or false. And if it equals true, we're going to do the thing underneath, and if it equals false, then we'll pass on to the next statement. Keeping that in mind, the fact that this expression evaluates to true or false will allow us to construct much more complex expressions in the future. Another point is we don't have to have elif or else. We can have an if statement all on its own. We could take all of this out, imagining we have an even smaller zoo. And if the user answers anything other than 2, we say goodbye. We will do more with conditions and branching later, but for now, this will get you started.